Good afternoon, Dr. Sandip Chatterjee. I welcome you
Good
on
afternoon.
Sustain, the
Mm.
YouTube channel of Institute for Circular Economy and SDGs. Today, we are very glad to have you on Sustain, and we are very much ready to listen you on e-waste management rules in India and sustainable recycling. As a scientist F at Ministry of Electronics and IT, you have been quite instrumental in developing this policy for our country and also now looking after the implementation of this policy. So welcome you, sir. Over to you, sir.
Thank you, Dr. Shalini. Good morning and good afternoon to listeners around the globe. I'm very happy to contribute my work in this forum, and I'm glad that Global Institute of Circular Economy has given me this opportunity. If we talk about the circular economy and resource efficiency, there are many aspects India should look into. We'll be touching upon what are the issues and challenges our country is facing. From the formation of the rules, implementation, the recycling option, refurbishment option. So I'll be touched upon what are the issues around us. If you see the our economical growth for last 3 decades, where electronics is one of the important components. You cannot escape electronics from the growth engine of any sectors you name. If it is IT, communication, strategic sector, uh, I mean, automobile sectors, any sector you name, electronics is the foundation, I should say. We, as a aspiring country of having a digital India and digital economy, we are seeing that 450 billion electronics, US dollars of electronics will be consumed by 2023.
Sir,
And as you see that
sir, I
20%.
put your camera a little bit up. Your camera, you can move a little bit up. Slow. Yeah, that's good.
It's okay.
Yeah, that's good.
So if you see the in waste stream, at least 20% of this electronics will definitely go to the waste stream. So almost 80 billions US dollars of materials will be in the waste stream by 2023 itself from the India. Now I'll come to the global figure. Very recently, one report came out from the United Nations University. They are saying that globally already 54 million metric ton of electronic waste has been consumed. Where we are the third contributor, India has already consumed 3.23 million metric ton of electronic waste, and our per capita consumption of electronics has also enhanced from merely 1 kg per inhabitant to 2.4 kg per inhabitant. But if you see, unfortunate part, out of this 54 million metric ton, only 17% is getting recycled globally. But if you see the material within that waste stream, that 54 million metric ton, around 25 metric tons of precious metal, precious resource materials are available. So unless we are extracting that material for our development or electronics product, so materials availability and Mother Earth is receding, so will not be able to contribute this much material for a future generation. So if you see the growth, year on year growth for India is almost 18% in the same report. So we'll be reaching almost 38 million metric ton by 2034. There is I have taken a projection. So, and mainly we have around 10 cities in our country. They are generating almost 70% of electronic waste. Now, if you talk about our rule, as we know, Ministry of Environment and Forest are the ministry. We are creating the rules of waste material, including electronic waste. We have two versions of the rule. One was in 1st of May 2012, Now we have another stringent version of the rule initiated from 1st of October 2016, and CPCB, Central Pollution Control Board, is an agency implementing the rule in the country, and State Pollution Control Board, other pollution control committees, etc., are helping the state government as well as the CPCB. This stringent version of the rule having there are many important features. Apart from manufacturers, they have included dealers also, and they have defined the white goods in on wider perspectives. They have included LCD, LED screen into that theme, and refrigerator, washing machine are also included. Another important part, if you see the schedule 1, which is defining different electronic waste material, only one product has been enhanced from the 2012 rule, that is basically CFL. But if you see the European Union rule, we have already included 642 products under that rule. But in our country, we have only 21 products. This is a, I should say, gray area. We should look into it, because electronics are used in, as I mentioned, in all sectors, but we have only considered 21 products in a waste stream. So that is not appropriate. Now, to attract the recycling business, this present rule has introduced the deposit refund scheme similar to ARF, advanced recycling fees, but it has not been implemented yet, I should say. And refurbishment is another part they have promoted in the rule, but still it is working in the informal market. None is a formalized. But one better part they have, this rule has included that any manufacturers can have a pan-India authorization. But earlier it was every state you have to take the authorization for operating. So that has been waived out. Now CPCB can authorize any manufacturer or brand owner. And if you see the present rule, along with the products, they have included components, parts, and peripherals. That is a good part of it. Now, to channelize the collection into the mainstream or formal sector, this rule has lots of initiative. Like PRO has been entertained, where producer responsible organization can be a cluster of all manufacturers or some manufacturers, and the responsibility of the manufacturer can be shared by this organization. And e-waste exchange also intermediary theme has been introduced. EPR, if you see, in 2012 also it was there, but this time they have come out with a target. So target started in 2017 with a merely 10%. By 2023, this target will reach to 70%. But if you see the European Union, we are reaching by 65% only. So this is very ambitious target, but you have to see on ground how it is panning out. Transportation of e-waste is also now in the present rule is very stringent. So the transporters has to show the challans and other things where this is moving, the waste material is moving. Now, if you see the best practices of EPR, lots of things are there in the rule, but we have to, streamline our entire management, US management. So to get the best, effect of the EPR in the true sense. This EPR has been introduced or understood as a better mechanism of channelizing the waste material in 1992. Then they thought is a life cycle of any product has to be thought of. But in 2004, it has been included from the manufacturing a product till its end of life. And after that, there are 384 different policies globally has been embraced for taking the advantage of EPR. That is why the UN report, UNEP report is saying around 375 billion of US dollars worth of waste has already been accumulated. So this is a good part of it. But if you see the India design of environment, so there are 5 different aspects of EPR. So design of environment, we are not still very much doing anything, but restriction of hazardous substance has to be ensured. Most of the products and components are coming from other countries, so we are not very much into it. But of course, we see globally product has improved. Information-based instrument where public awareness and other things also required to be strengthened. Here we have a weakness. As I already told, advance deposit fee, it is there in the rule, not been implemented yet. Regulations, standards, and monitoring, here also lots of we have to work hard. And lastly, this is our own subject, recycling technology, promotion of innovation in recycling technology. Lots of miles we have to go for getting it streamlined in our country. Now this is one snapshot of how this EPR target is comparing in other countries like India. As I told, we are approaching 70% by 2023. If you talk about China, we do not have similar target. They are saying that 2020 they are introducing something, by 2025 they will be implementing. If we talk about Korea, by up to 2019 they have some 6 kg per capita target for electronics. And if you talk about Japan, up to 2020, 1920, we have a refrigerator of 50%, we have an air condition of 60%, and TV for 50%. So other products, they have no target. So this is the scenario in other country. European Union, of course, they have robust mechanism for monitoring this EPR target, and by 2025 they are to reach around 65%, and by generation it should be 85%. Now if you talk about the promoting green product, as we know, by 2002 European Union has identified 6 element as a hazardous element with some target. Our rule still maintaining that 6. If you see the European Union rule, they have almost 15 different items has been included for as a ban item, but we have not done that. But one good part of it in this present rule, they are saying if you have a non-compliant ROH non-compliant product in the market, that brand owner should take back all that product from the market, and they have to they will be penalized for that. But this is on the rule itself. There is no implementation on ground yet. And CMAT is our lab, Center for Materials and Electronics Technology, Hyderabad, is the only government lab can having testing facility and certification facility of the ROHs. Now, if you talk about refurbished market, there is a very important point in circular economy. But we have a global market of around 10 billion consumer electronics. Another data is saying 334 million units of smartphone is sold into the second-hand market. And in India also we have a 4 billion used smartphone market. And ASSOCHAM figure is showing 100 crores of electronics, second-hand electronics in our country. So market is growing by 35%. But one thing we should know, this market is predominantly in informal sector. So we do not have a formal market. Now I will give you some of the 2-3 slides to show why it is formal market is not coming in the country, because few industry association is pushing India to create a refurbished hub, because lots of developed country, they are interested to send their second-hand product for repairing in our country, but that is also not allowed by the present rule. And also refurbishment of a product requires lots of litigation that I will be discussing here. This is one snapshot in 2018 has been taken. If you see in India, refurbished phone sold, smartphones sold 41%, and new phone sold 17%. Similarly, in US, if you see, new phone is minus 21%, and refurbished phone is 20%. So that shows that there is a market of refurbished material. People are aware, they are interested to spend money on refurbished product, but we should see how legally it will be feasible. So there are 3 different points I should mention. One is fundamental legal, non-legal barrier, that is preventing accessibility of repairing, that is creating your IPR infringement, product designed for obsolescence rather than longevity, total price of the repair and other competitiveness. There's lack of awareness. There is lack of knowledge, tools, manual, spare parts are not available. So these are some of the issue. And finally, of course, customer preference and attitude for favoring the repair, the culture aspects about the making repair less desirable, independent of the cost and other barrier. So if you talk about the European Union and USA, I'm trying to give you some sense what are the legal barrier or technical barriers are not helping the refurbishment. Like if you talk about consumer, this is end user license or sales contract forbids unauthorized repairing. So if you are having some company smartphone, you are not allowed to repair it in other unauthorized place. And where the software enabled part and other parts, if you're trying to rectify or repair or amend, so this is the infringement of their IP laws. Lack of awareness, there is consumer rights. What is consumer rights? What is the legality of the warranty? What is the right to repair? These are the things that consumer not aware of. So design lifetime, planned obsolescence prompt prevents repair. Similarly, for unauthorized repairing center, this end user license and sales contract forbids them for disassembling any local parts of any product. Of course, disassembling proprietary screws, slim, compact, sleek make products, non-removable batteries is difficult, so repair becoming impossible. Repair amounts, construction and modification of the patented article constitute the direct infringement of under patent law. Of course, technical lock of the software, digital right management, and technical protection measure, these are the other issues that is protecting software to amend it. And software repair activity, copying codes, infringement, no updation of the embedded software makes the repair device less functional, pose the security threat, and loss of ability to the retrieve data. And if you talk about the spare parts, OEM refuse to provide spare parts and software support to the repairing products from unauthorized place. Manufacturing, selling and importing of unauthorized parts invite trouble under IP infringement patent law. Partial design patent and other parts is also coming under the design law. Trade law prohibits them to do so. And designing of measure and software doping prevents product from functional to the third party. Another important thing is tool. So no obligation for the OEM to sell the proprietary tool to the unauthorized repairer, and unauthorized distribution of software, restoration of operation of disk is unlawful and breaking the technical software laws. And access to the manual, access to the schematics is also not allowed. So these are the some of the things. If in our country we are not making it legally possible, then the repairing market or refurbished market cannot come into the formal sector. So this is some of the things one should look into. Now in a snapshot, so some of the law internationally is protecting OEM, like repair under IP law, exhaustion doctrine, anti-circumvents, copyrighted repair manuals, and design of trademarks. So these are the under IP laws. Competition and antitrust law and repair restricted contextual clauses. So these are the some important legal provision in internationally. They are protecting OEM. Now some activity has started in USA and Europe, which is protecting consumer as well. So if you see the planned obsolescence, France is the only country it is considered as a criminal offense. So first country, it is initiated from 2015. If some smartphone is having a usable life and you are going for a recycling, this is a criminal offense in France. And warranties, so lack of information, misinformation, enforcement about the existing consumer rights, so these are also protecting consumer. And if you're talking about design requirement, make the product more durable, this is the move. easier to repair and upgrade the remanufacturing. So Motorola is a company who has started the modular phone. It's not very popular, but that attempt is also starting. How to get use of 70-80% of the component of any product usable and reusable to the remanufacturing. And fair bill. So OEM should also reduce the repairing service cost so that people should go for repairing. That is also another hindrance. So they are not allowing to, repairing is not attracting consumer anymore, because another new product is having the similar price or slightly higher price. That is also hindering, a consumer for a repairing to the product. Now, what should be the next course of action? This is the my slide for last slide for for refurbishment. So globally, R2R is the new movement. So right to repair. So that will allow consumer to ability to repair and modify their own consumer electronics, and where the otherwise manufacturing forcing consumer to only use their services. 4 states in USA has initiated this R2R laws in 2014 to 16, and by 2019 there are 25 states had adopted similar rule. And European Union in 2019 they are saying the manufacturers are mandated to supply the replacement parts for 10 years. So this is a very big decision European Union has taken. But there are different lobby working against it also. So OEM considered it is a breach of IP law, threat to the people's safety, and argues the hackers could insert the vulnerability and in repairing device and affects the user privacy and security. And in favor, people are also lobbying, like slowing the rate of recycling, reduce energy consumption of recycling, as well as the fresh product and hence environmental protection. So this is basically, if you are helping OEM, this is contradicting our circular economy and resource efficiency. There should be some balance. Now, if we talk about our country, US rule is allowing refurbishment, but in from my ministry there is another provision like CRO or CRS, where compulsory resistance obligation is there for new product to the market. So CRS is not allowing to the refurbished product to the some standard testing standard, unless you are having a testing standard for the refurbished product. So refurbished product cannot come legally to the market. So that is two contradiction in the two rule. I think some bridging effect we should mention in the rule, so that this refurbished product should be easily available to the common man. Now these are some of the companies engaged in India in refurbished market, but legally how they are managing, and if the product is coming to legal provision, what will happen, I cannot comment on this. Now lastly, my favorite topic, e-waste recycling. That is the last part. So one is law, another is refurbishment, where the laws are not there in our country. We have to work hard. Now the recycling, as you see, by 1970 to 2010, if you see the consumption of material, fossil fuel and other things, enhanced 420% in the country, in our country itself. So that is very alarming. So where from you will get that material? And if you see the so secondary material or secondary materials are available from the urban mining, which is basically electronic waste. So how to recycle it, how to enhance its resource efficiency, so the material reaching to the fresh product can be enhanced. But if you see the recycling scenario, though we have a rule, though we have a formal recycler, but still 95% of recycling is being done in informal sectors, and formal sectors are not getting sufficient material, and informal sector is using very unscientific means, so that is polluting the environment. That is the scenario. But if you see one snapshot of the material available, like 54 million metric ton of electronic waste is available globally by 19. So if you see that number, and Indian number is 3.23 in that same report, so we can see almost one available in that US, and 13%, that means 0.4 million metric ton of non-ferrous, where gold, silver, copper is also there, that is available in that US. Plastics is almost 21%. So there also you have engineering plastics that is very costly. So if you see the material worth available in Indian US is also very significantly high. So, and if you see how to manage it, how what should be the technology cost, what should be the machine cost, that also one should see. If you are dismantling any electronic waste, whatever I have shown in the black font, that is manageable in our country. You are having a large and small structure, metal structure, plastic structure, some glasses, and you have a printed circuit board, you have some lithium ion batteries, and you have some phosphor, rare earth material. So these are, I can consider a red part which requires a technology intervention. So our ministry initiated some projects in R&D stage, then upscale it till since 2007. So one project in National Metallurgical Laboratory in Jamshedpur we have tried. It is all manual dismantling. After that, printed circuit board is pulverized. Then we used separation method like eddy current separation, magnetic separation, gravity flow separation to metal rich. Then hydrometallurgy we have used. In another method we have done with our own lab, CIMET Hyderabad and E-Parisara Bangalore, where we depopulated the board. That is possible in our country. We depopulate the board. Why you have done it? If you see the printed circuit board, where the connectors, chips are connecting, having the gold. So entire board is not having gold. So if you can depopulate it, then the depopulated board is containing only copper. So the process will be accordingly tweaked so that we can use the less energy. So in one go we can use that components and connectors, and bare board can be processed in one way. So in that method, manually segregated till the PCB recycling, PCB stage, then pulverize as I mentioned in NML Jamshedpur process, then segregating, then hydrometallurgy has been used to extract the four metals, copper, gold, silver, palladium. And in the other method like cement and E-Parisara, we have done the depopulation first, then depopulated board we have pyrolyzed, then the calorific, the epoxy part has been converted to the calorific value of the oil. Then we have a black copper. The black copper has been calcinized and then smelting. And then we use the electrolysis method. From black copper, we have a pure copper. And from slag, we have extracted the gold, silver, and palladium. So this is the metal recovery. We have found that this method is giving a better output. So we have upscaled this plant in E-Parisara as well as in CIMET lab. Apart from metal, we have a 27% of plastic. If you segregate, there are 7 different categories of plastics, and out of that, 3 categories of plastic are very high value engineering plastics. So we have converted out of that 27% of plastic, 78% we have converted to the master batch, and we have taken the toxicity test for the master batch. Then we have converted that value added product with the master batch. Like we are using that master batch in the car bumper, car interior, and we have taken the that BIS certificate on that product. So this is proving that material, the plastics are coming out, can be used for a value added product. So this is the process flow chart of the plastic conversion from a electronic waste plastic or WEEE plastics. Now this is the upscale effort of the PCB recycling. So in 100, okay.
Yeah.
Should I continue?
Yeah. Yeah.
If I see that these are the upscaling effect of the skin of our technology repository. So from that recycling plant, we can extract the 35 metric ton of different type of materials, and from the lithium ion battery also 10 metric tons of different type of materials per day. So so this initiative has enabled us to convert the wires, connectors, CFL, fluorescence lamp, rare earth material from phosphor, as well as hard disk. So one very interesting side I should show. If you see the 2016 to 2019 global generation of e-waste, that is the enhancement of 10%. But in the enhancement of 10% of the product, I mean electronic waste, if you see the precious metal, it is going down. Something is 13%, gold is 13%, 15%, silver is only 13%, and copper is 11%. That is dismotivating the formal recycling. So product improving its design, but using less precious material. Very interesting side. Now, what to do? My last 2-3 slides to showing what to do. We should promote the refurbished product, as I told you, and we should upgrade the informal operation in our country with a frugal technology. And also, we should create a ecosystem for dismantling and segregation in non-usable product, and create infrastructure like eco park to place the recycling process in one place. So we talk about the 3 R's: reduce, reuse, and recycle, but people are now talking about 8 R. I think Dr. Shalini was mentioning about 7 R. Now, repair, new manufacturing, redistribution, and production side redesign, rethink. So these are the I know Shalini was mentioning about 7 R. Now, circular economy, resource efficiency, reduce dependency on the raw material, produce adequate legal provision to make refurbished product legal. EOS rules should be sound, embrace entire electronics item, not only 21 product, create adequate infrastructure, provide affordable technology, create the awareness to the stakeholders, and next to the benchmarking to the create facility. Thank you, Dr. Shalini. Over to you.
Thank you. Thank you so much for providing these insights.